Okay, welcome 7th graders to your first assigned video lesson. We're starting in chapter 10 of lesson 10.1, and if you're following along with your book, that's going to be on page 528. Here our target is that we can identify linear functions. We've heard the word linear before, and we need to remember that linear means that we are going to be looking at graphs that have straight lines. Just as the word says linear, meaning line, we're looking for straight line graphs. So that's something to keep in mind as we go forward for today. Here, we're looking at another review of vocabulary word. It says rate of change. We're trying to find out if a table with some ordered pairs of x and y that form a graph, if it is a linear or nonlinear function, meaning if the graph is a line or not a straight line. So to determine if the table represents a linear or nonlinear function, we look for the rate of change. If you remember, our rate of change is kind of like our slope, our change in our y values over our change in our x values. So when you're looking at a table, you can look at the change in y compared to the change in x. And as we know, constant means the same. So when we look at example 1, we see that the y value is going down every time by 15 as the x value is going up by 2 at the same time. So here we look at our description to tell us if this is linear or nonlinear based on the rate of change, the change in y over the change in x. And it says as x increases by 2, y decreases by 15 each time. The rate of change is constant, so this function is linear. So every time we're going to see a change of negative 15 over 2. So that if we did a graph of this, that's what our slope would look like. Therefore, it is a linear function, meaning it is a straight line graph. Looking at number 2 then, we see we're going to look for the same things. Our change in y compared to our change in x. Are they remaining constant with each other or are they not? That's what's going to tell us if it is linear or nonlinear. So here we see as x increases by 3, which it does every time, y increases by a greater amount each time. Y is not consistent, so the rate of change is not constant, so the function is then non-linear. It is not a straight line. So why don't you take a minute to check your progress, pause the video, and check your examples for A and B. Then you're unpause. Obviously, we'll see if we get the right answer. So we're looking at our change in y. Looks like we're going down by 4, or down by 4, and down by 4. So far, y is constant. And we see that x is going up 5, and up 5. So since both x and y are constant, our rate of change of y over x is consistent. So that is a linear function. Looking at example B, we look for a change. We see that we're adding by 2, adding 6, and adding 10 for y. By our x values increase by 2, by 2, and by 2. So here we see that as x increases by 2, y increases by a larger amount each time. So this is a non-constant rate of change. So this is a non-linear function. So that is how you tell by a table. Just a little bit of looking kind of for your slope. If you're given a graph of a line, then you can tell if it's linear by, well, what we know. We know a linear function, we already decided, is a straight line. So anytime you see a straight line, you're going to say that that is a linear function. If it is a non-straight line, it's non-linear. So that would be something like if it's curved at all. So looking at example 3, we see, what do we see? A line that kind of looks like a U or a V. It has a curve. Since it has a curve, it is nonlinear, and we would explain that by just saying that it is a curved graph. Not so bad, right? Number 4 as well. We're seeing this is a curved graph, so we're going to say that this is non-linear. non-linear. Take a minute and pause your video and see if you can figure out if C, D, and E are linear or non-linear graphs. When you push play again, then you'll be able to find your answers. So looking at C, we see that there are no curves. It is a straight line. We would know that this has a negative slope since it's going down, but it is a straight line, and this is a linear function. For D, we see that we do not have straight lines, we have curves rather, meaning this is not going to go by a constant rate of change. So this would be a non-linear graph. Just as E, two separate graphs that are both curves, those are going to be non-linear as well. So far, so good, I hope. Make sure you're pausing and writing down some notes or writing down some questions that you can bring to class tomorrow. Lastly, we're going to be able to find out if an equation is linear or nonlinear by using the form y equals mx plus b, which we remember is slope-intercept form. This is where m represents our slope, which is our constant rate of change. So if we can write a function in that form and we have a constant rate of change, it's going to be linear. Take a note of the study tip here though. It says always examine an equation after we've solved for y to see that the power of x is 1 or 0. Okay, so if we have something that looks like x to the second or more, that is going to be non-linear. So we have to make sure that's to 1 or 0 power. So looking at example 5 and example 6 now. We see that y equals x plus 4. We're going to determine if this is linear or non-linear. So we want to say, can I write this in slope-intercept form? I know that I can write this as y equals 1 times x plus 4. So I have a constant rate, a slope of 1. So this is a linear function because I can write it in slope-intercept form. Over here, I have y equals 6 over x. I could not write this as y equals mx plus b. And if we go back to our study tip, it sees that x does not appear in the denominator. So since x is in the denominator, I know that this cannot be written in slope-intercept form where I would be given a constant rate. So this is a non-linear function. Again, take a minute to pause your video and try examples F, G, and H on your own, and then come back to check your answers. For F, I see right away this is sort of in the form of y equals mx plus b, but like my study tip above told me, I'm supposed to look to see if the power of x is more than 1 or 0, and if it is non-linear. So since this is a power of 3, this is going to be non-linear. So I'm going to say this is a non-linear function. And since it's asked me to explain, I'm going to do that because x is to the power of 3. Looking at G, I can write G as y equals 3x. I can write that as y equals 3x plus 0, my y-intercept being 0. Since I can write it in slope-intercept form, this is a linear function because it does have that constant rate of change. Lastly, h, y equals x over 5. This I can also write as 1 over 5 times x plus 0. I can just put a 1 with that x on top, and that's 1/5 times x. So this is linear because it has a constant rate of change. I'm going to write that as constant rate of change for now of 1/5. So that would form a straight line. Please make sure that you write down any questions that you have. You had some good notes so that when you come to class tomorrow, we can do our best on lesson 10-1.